In this lesson, we're going to look at averages. We're going to look at how to obtain averages from a list of data, how to obtain averages when the data have been grouped, and finally, when to use which type of average. Now, what is an average? Well, after we've collected data, we usually want to summarize it, and an average is one way of summarizing the data. Now, there are three different types of average. The first is called the mean, and we find this by adding up all the recorded values and dividing by how many there are. This can be written as x bar equals sigma x divided by n. X bar is a symbol for the mean, sigma means add up or sum, x is the individual recorded values, and n is the number of values recorded. Now, the second type of average is called the median. And to obtain the median, we put all the values in ascending order and pick the middle one. And the third type of average is called the mode. The mode is the most common value. So let's have a look at an example. Let's imagine 11 students each did a test. And these were their marks. So the first student scored 0, second student scored 2, and so on. The 11th student scored 10. Now let's calculate the mean, the median, and the mode for that list of data. So to calculate the mean, we have to add up the x's. So we have to add all of these up, and we have to divide by how many there are. Well, there are 11 of them. So the sum of all of these is 66. We divide by 11, so we end up with 6. So that is the mean mark for the students. Now, to obtain the median, we need to first of all have the data in order of size. Now, in this example, the data are already in order of size. We want to find the middle one. Well, there are 11 pieces of data. The middle one is the sixth one, which is here, so the median is 7. Now, the mode is the most common, so we can see that 5 appeared the most, so the mode is 5. Sometimes the data aren't arranged in a list. For example, if there are large numbers of data, then often they can be grouped and put into a table. If that's the case, this is how we find the mean. We multiply each value by its frequency, how often it occurs. We then add up all of those answers, and we then divide that by the total number of frequencies. So our formula for the mean now becomes sigma fx divided by n. So that means we multiply the frequency by the value, add those up, and then divide by the total number of observations. Let's have a look at an example. The attendance figures for a 10-week course were as follows. One student attended 3 times, one student attended 6 times, 3 students attended 8 times, 6 students attended 9 times, and 8 students attended 10 times. So we want to find the mean number of times attended. So to do this, we need to calculate f times x. So the frequency by the value. 1 times 3 is 3, 1 times 6 is 6, and so on up to 8 times 10 is 80. We then need to add up all of these. That gives us sigma fx. We then need to divide by n, and n can be obtained by adding up all the frequencies. So here there were 19 students altogether. And then to find the mean, we simply divide this by this. And that gives us 8.8 times. Now let's have a look at how we'd find the median of that data set. So to find the median, what you need to do is find the cumulative frequency. Now, cumulative frequency is a running total of the frequencies. You then need to find the middle value. So the middle value is going to be the cumulative frequency plus 1 divided by 2. That'll give you the halfway point. And you then find which group contains that middle value. Let's have a look at it in practice. So this is our data set, same as before. So what we need to do is find the cumulative frequency. So the frequency starts at 1. We then add on another 1 to give us 2. We then add on another 3 to give us 5, another 6 to give us 11, and another 8 to give us 19. We then need to find which the middle position is. There are 19 people altogether. To find the middle position, we do 19, you add 1 and then halve it, which gives us 10. So we know the 10th person is the middle one. Now we know the first person is in this group, the second person is in this group, the third, fourth and fifth are in this group, the 6th, 7th, 8th, 9th, 10th and 11th are in this group, so therefore the 10th person is in this group. And this group corresponds to 9, so the median is 9. Now let's find the mode. Well, the mode is the value with the highest frequency, so this is relatively straightforward. We just look for the group which has the highest frequency. So in this case, we can see that 8 is the highest frequency, and that corresponds to the value of 10. So the mode here is 10. Now, you can easily check your value for the mean using your calculator. Let's demonstrate this using an example. In this example, our variable is salary, and the frequencies are here. So we can enter this data set on our calculator as follows. Now note that these instructions are specifically for the Casio FX83. Whichever calculator you have, there will be similar buttons on it. So the first thing you do is press Shift, Setup, Stat, Frequency on, and that ensures that you can enter the data in a table form. You then press Mode Stat 1 var, and that takes you to the data entry screen. And here you enter the data. So you enter each value, and you press equals after you've entered each value. And similarly, you enter each frequency, and again, you press equals after you've entered each frequency. Once you've entered all the data, you press AC, and that takes you out of the data entry screen. Now you can find out what the mean is of those data. To do that, you simply press Shift, Stat, var, x bar, equals, and it'll give you the mean. So in this case, 29.46 thousand. Now, in the examples we've looked at so far, the responses have all been a single number. Sometimes the response might be a range of numbers. So for example, let's imagine 30 students were asked, how many times did you post something on Facebook over the weekend? And they were given these 5 choices. for their answer. So let's imagine this is a summary of the responses. So 4 students didn't post anything, 8 students posted 1 to 5, and so on up to 2 students who made 16 or more posts. Now, this raises problems when we're trying to find the mean, for example, because if you remember, to find the mean, you multiply the frequency by the number. But the problem is 1 to 5 isn't a number, 6 to 10 isn't a number. So instead, what we do is we use the mid values for each group. So instead of 1 to 5, we write that as 3, because 3 is halfway between 1 and 5. 6 to 10, we can use 8. 11 to 15, we can use 13. This one says 16 plus. We don't know what the highest value is here, so usually we can just assume it follows a similar pattern to the earlier groups. So let's assume this is 16 to 20, so the mid value is 18. And now we can just use the same methods as before to find the averages, because these are now our x's. However, be warned, once you find the mean and the median and the mode, etc., they are only going to be approximations. This is because when you take a mid value, say this one for example, this represents 1 to 5. So we're assuming everyone who gave the answer to 1 to 5 actually only posted exactly 3 times. And everyone who said 6 to 10 posted exactly 8 times. This probably isn't true. So it's only an approximation or estimation when you find out the means, median and modes using midpoints. So there are 3 averages: the mean, the median and the mode. So when do we use which one? Well, often it depends on the type of variable involved. If you remember, there are nominal variables, ordinal variables, and discrete scale and continuous scale. So if the variable is nominal, remember this means it's a category. Usually it's words, like what gender are you? What town do you live in? In this case, you can't do calculations on words, so the only average you can use when it's a nominal variable is the mode. So it's which country do most people come from? Which is the favourite football team? They're the only kind of things we can answer when we have a nominal variable and we're trying to find an average. How about ordinal variables? Well, ordinal variables, if you remember, are ranked categories like small, medium, large. Again, we can use the mode. It's a category, so we could say which was the most common answer. But we can also use the median, and generally the median is preferred to the mode. So how do we find the median when the categories are words? Well, we basically just assign numbers to these categories. Remember, these categories can be ranked. They can be put in order. So we can assign the rankings to them. And usually we start with 1 as the lowest rank. So we call that one 1, that category is 2, and that category is 3. Let's look at an example of this. So here we're going to find the median for data from an ordinal variable. Imagine some people were asked the question, how much do you like vodka? And they were told to give the answer either not at all, a little, quite like it, or love it. Now let's imagine 5 people said not at all, 3 people said a little, 9 people said quite like it, and 2 people said love it. So we want to find the median here. So what we need to do is assign number values to these categories. we can now just find the median as we did before. We first of all find the cumulative frequency, and we see where the middle position is. N is 19, 19 plus 1 halved is 10, so the median is the 10th one. We can see that the 8th person was in this group, so the 10th person must be in this group. So the median is 3, which corresponds to quite like it. So which average should we use if we have a discrete scale or continuous scale variable? So a reminder, a scale variable is one which can be counted or it's measured using a recognisable unit like centimetres, kilograms, etc. Now in fact you can use the mode or the median or the mean when it's a scale variable, but most of the time it's best to use the mean because the mean takes into account every single value, every single observation. However, sometimes we shouldn't use the mean. Let's look at a couple of examples where this is the case. In this example, we're going to look at when the mean isn't necessarily the best average to use for a scale data example. Now this example is to do with graduate salaries. A well-known university states in its prospectus that the current average salary is £60,000 for students who graduated from a particular course 2 years previously. So this all sounds very good. The university is implying that you'll earn lots of money if you study at their university. However, if we look a bit closer at the data, let's show it in a bar chart and let's see what we have. So we can notice that the majority of people earned about this much and one person earned this much. Now the problem with the 60,000 figure quoted by the university is that they were using the mean. Now to obtain the mean, you add up all the values and divide by how many X students there are. But the problem is this one very high value disproportionately bumps up the average. This particular person had become a Premiership footballer, so they weren't necessarily representative of all the graduates. So in this case, when we have one very high value, we often say the data are skewed. It would have been much better or more representative to use the median. The median is the middle value. Now the median will be the same whether this highest value was 750,000 or 50,000. So the median is much better to use if there are extreme values. And our second example, let's imagine you were asked how many arms does a human have on average? Well, if we think about it, the vast majority of people have 2 arms, but some people have 1 arm or no arms. Hence, if you did calculate the mean, it may be around, say, 1.995. However, saying a human has 1.995 arms on average could be considered misleading, as a huge majority have more than that. It would probably be much more useful to state the mode, which is most people have 2 arms. So that would probably be the best average to use in this particular example. So a reminder, in this lesson we looked at how to find the 3 averages from data when they're in a list. We looked at how to find the 3 averages when the data are grouped, and we looked at when to use which particular average.